Everybody knows that if you want to rule the Nerf battlefields, you need to get yourself some 3D printed foam flingers. Speed, power, accuracy, customization, and just pure aesthetics. Nothing hits quite like your own custom dart blaster. And everybody has to start somewhere, but what if I were to tell you that this thing right here only took about 15 hours to print, cost less than $5 in 3D printer food, and the only hardware you need is this. And yet it'll fling 6 of these little half-length darts at some pretty astonishing velocities. And not to mention, it's a ton of fun. And all you need is one of these, a Bambu Labs A1 Mini, a $200 3D printer. 3D printed blasters are too expensive, I see constantly in my comment section. Well, dear viewer, why not save a bunch of money and just build it yourself? Or make money running your own 3D printed store. In this video, I'm going to show you everything from unboxing the printer to building and firing a custom Nerf blaster that only requires an elastic band in terms of hardware. Everything else is 3D printed and the build is as simple as Lego. Buckle up, Buttercup, because it's going to be a bit long to make sure we don't leave any stone unturned, but use the handy little navigation bar thing to skip to parts if you need to. But I don't have a printer, those are too expensive! Well, I'm going to show you how reasonable it is now. Because thanks to Bambu Labs, we have 2 of the best printers on the market in the budget category that'll tackle absolutely anything you throw at them with essentially 0 effort on your end, with a higher speed and quality than you've ever seen before. Don't believe me? Well, basically every single store in this hobby already uses Bambu Lab printers. So if that isn't a ringing endorsement, I really don't know what is. These printers can't be beaten for the price tags, and honestly, they perform better than many printers that cost double or even triple their price. Also, little note, Bambu Labs sent me an affiliate link for all this stuff, so if you're in the market for anything, even if it's just more filament, consider using that link as it massively helps out the channel. Link, use it. Got a friend who's using 3D printers? Give him the link. But hey, let's talk about Bambu Labs first and why these printers are the best, especially for first-time buyers. These are their budget offerings in the small but powerful line of FDM, that's fused deposition modeling, or basically where it uses the plastic filament that's pushed into a hot end and then squirted down onto a build plate. Style of printers, but in all honesty, this is really all you need. And I can say all that as someone who's owned one of their Bambu X1 carbon printers for quite some time now. Most blasters are just printed out of a material called PLA, but the new A1 series of printers can do PLA, PETG, TPU, or basically any filament that doesn't require the printer to be in an enclosed space. And there are many times I wish I had waited for the A1 series before buying my X1 carbon, because I could have literally bought like 5 of these for the cost of that one printer, and I only ever print PLA and PETG to begin with. But the 2 printers I have in front of me are the Bambu Labs A1 and the A1 Mini, ringing out at $300 and $200 respectively during their Black Friday sale. Remember, use the link in the description. Simply put, the A1 Mini and A1 are basically the same printer, with the A1 Mini sporting a 180 by 180 by 180 millimeter build plate, which is insanely compact but reasonable and functional for lots of blaster builds. And the full-sized A1 with its 256 by 256 by 256 build plate, which will tackle absolutely any blaster you want to print. Both printers are not only stupidly fast with some insane out-of-the-box high quality and will probably ruin every other 3D printer you've ever seen in the past decade, but they are really simple to use. Seriously, mom, dad, grandparents, this is an excellent holiday gift for a teenager, especially if they're in the hobby, because one of the biggest problems with 3D printers is figuring out what to use them for. But if you're already into Nerf and Nerf modding, you'll have hundreds of options of parts to print out, from simple ergonomic and cosmetic upgrades to full-on blasters that are some of the best the hobby has to offer. All of this while developing multiple STEM skills. It's a win-win situation for everybody. Even the filament is pretty cheap, ranging anywhere from $13 to $20 per kilogram, depending on what you're using, and that one roll can print out a lot of things, as I'll show you in this video. And I sincerely mean that. These printers are basically automatic in every way, from automatic bed leveling, filament runout detection, filament jam detection, power loss recovery, automatic flow calibration, one click to print, active flow control, Wi-Fi direct drive extrusion, and is compatible with a wide range of plastic filament types, both Bambu's own and of course other manufacturers you'd find on the likes of Amazon, like eSun or Overture. They even have cameras in them to monitor your prints, and both printers are very easy to set up, but do require you to remove some screws and add some more screws in other places to help with shipping stability. They have step-by-step instructions, including all the tools and even some maintenance parts, and you will have everything up and running printing within minutes of removing them from their cardboard prisons. Something to notice that Bambu Labs is also famous for their AMS, or Automated Material System, which does a few neat things such as automatically switching to a new roll of filament mid-print when one runs out, as well as easily swapping to different colors and materials during the printing process, allowing you to make some absolutely beautiful multicolor prints without any paint or hassle. Well, a little bit of hassle. Every time the printer starts up or changes out a different roll of filament, it'll extrude a little bit of plastic to purge the nozzle and immediately knock it off, usually kicking a small mess of melted plastic off to the side. If you have lots of color switches, for instance, you're going to have a lot of filament wasted this way. But that's a small annoyance and price to pay. The printer does its best to minimize this, and one of the first things I recommend printing is a plastic collection bin, or just put a cardboard box out to the side to catch it. The A1 and A1 Mini use what's called the AMS Lite, which is a smaller, lightweight version of their original AMS system. Long story short, it's better designed for multicolor printing, as all 4 rolls feed right into the hot end. But it isn't sealed like the original AMS, so you're more susceptible to your filament gathering moisture. And moisture is bad, you don't want that. You don't need the AMS Lite to print anything, and it's a $150 addition when it comes to buying either printer, but think carefully if you want to do custom color or large prints that could use the automatic roll switching, because if you decide you want one later, it's $250 a la carte. Actually, before we get way too deep, let's think about budget here. For the bare minimum, you absolutely cannot beat the $200 A1 Mini, whose only fault is that its slightly smaller bed size can pose a problem for a lot of the designs out there. Many, most even, of your projects will fit on a printer bed this size, but the larger A1 will not only leave you completely unhindered, but you can genuinely fit more on the print bed, which will benefit you a lot. Think of your printer as a timer in a video game, and you'll realize that a lot of your printing is going to be done overnight while you're sleeping for maximum gains. Don't leave any XP to waste. 92 is half of 99. If you could swing it, the A1 is a slam dunk, but the A1 Mini, especially for its size, will get a lot of the job done. Now to the fun stuff. We're going to be printing one of the blasters from LeedleDynamic off of Etsy. You can find these files on their Etsy, you can buy them, download the files, and print them yourself. That does mean you'll have to purchase these files, and Bruce deserves the coin for his effort in taking the time to design these, and Bruce has no idea that I'm doing this, as far as I know. But I've already printed out some of LeedleDynamic stuff in the past, and it's absolutely intense because the only hardware you need is a simple 4mm diameter bungee. $12 of this stuff will probably string dozens of these blasters together, and the performance is no joke. The Replicant that we're going to be printing today is a revolver that doesn't require anything external to function besides the band. But LeedleDynamic has a bunch of different options for blasters, including some that use magazines, and yes, you can even make NERF magazines out of just 3D printed parts. Something to notice that the Bambu series of printers are closed source, which some people frown upon, but for our purposes as a first-time beginner, this is a huge boon. You will need a smartphone and an internet connection for initial setup and to make a Bambu Labs account. This sounds annoying, and bear with me here, this app is one of the best things about these printers, and I'm not even joking, we'll talk about it in a little bit. And while you can do a lot of everything with just your phone, you will need a computer with an active internet connection. Well, technically. The printer makes this whole setup super simple with its full color touchscreen, allowing you to connect to a network, input the password, and your phone can scan the QR code to download the app and bind the printer to your Bambu Handy account. From here, you can do a test print, load up either the tiny amount of filament included or a brand new roll of filament and print yourself a benchy, or that little boat thing that you see everybody always printing. These are used to test your printer to make sure it's working, as they have all these weird little angles and nooks that some printers fail to print. Also, your printer came with the stuff to make a scraper, and you'll probably need that. So I recommend you print that next. This will help you get rid of the little bits off your printer from the calibration testing and whatnot. Once you've got everything set up and the printer is live, updated, and tested, we'll move on to the slicer, or the Bambu Studio program for the computer. A slicer turns your 3D models, or STL files, into G-code for your printer to basically program it to run. It basically does all this automatically, but there are a few steps to follow and things to look out for. The files from LeedleDynamic have a README included that tells us the settings and what to use for printing parameters, which is easy enough to set up. The last thing to think about is what filament you're using. Bambu makes this as easy as possible, especially if you're using one of their own filaments and the AMS, which, get this, will automatically read an RFID tag inside the spool and know what filament it is and automatically apply its best settings and even know what color it is. Otherwise, if you buy a popular brand off Amazon or Bambu's own filament, there is a drop-down menu you can use to choose what it is. Most rolls of filament will also just tell you what the temperature ranges are the best, so it's pretty simple. For example, most PLA is printed between 190 degrees C and 210, 215 degrees C. The Bambu Studio Slicer is simple. Once you're logged in with the same account that used the Bambu Handy app, we're going to unzip our files, click on the Prepare tab, and we'll see things like what printer we're using and what build plate we have. Make sure your printer is selected, make sure it's set to a 0.4 nozzle, which is what the printers come with. From there, we'll make sure we have the same plate selected as what the printer came with, and select our filament. If you need to manually set up the temps, you can click here and change everything. Bruce says little in the README, as it's kinda up to you, but he tested it at 20% infill, that's the density of the part, with 0 being hollow and 100 being absolutely solid, with 3 walls, which means the amount of walls that make up the outside surfaces of the part, with more walls meaning more strength. Both of these things are super normal settings that you can change in the strength tab with the wall loop setting and the infill/wall overlap setting. All of the parts are pre-orientated, which makes things super easy, and Bruce already put the parts into different folders for different colors, so you don't have to do any guesses. And Bambu Studio lets you prep multiple build plates, making it easy to set everything up and saving it as a projects file, so once it's all set up and printed, you can come back to it with all the parts laid out just how you had them before and print it again. Now, the most basic rule for printers is that you can't print anything in the middle of the air. So if there's an overhang on the part, the printer needs something that acts like a surface to print on, which is where the supports and print orientation comes in. Think of supports like scaffolding, a skeleton structure built up that's just there for the printer to be able to print the main body on or fill in a gap that's there. Bruce says that these don't need supports, but if something looks wild and you just don't trust it, and you can't figure out a way to make it lay somewhat flat and has a massive angle or just a flat out 90-degree overhang, you'll probably need to turn on supports. Set up your build plate. You could stuff it as much as you'd like, but that does mean if you have a failure, which does happen every so often, it'll ruin the entire plate. If you're already around the printer while it's printing, you could just do things one at a time, but if you want things to be set up for the long run, chuck everything of one color on the plate and let it rip. Click the slice plate button and it'll generate the entire thing as the printer will see it, and you can even see the path the printer will take as it builds your part. This is also where we'll see exactly how much filament is used, where it's used, and the total time for printing. For example, the frame main here in the settings Bruce suggested will take 142 grams, or a little over 1/10 of a roll of filament, and will take overall about 6 hours to print. If we pop the frame front piece on there too, both from the main color folder, we'll have a little over 8 hours of print time and 225 grams of filament used, which again is almost about 1/4 of a roll. Adding all these colors to different plates and slicing everything, then totaling the times of filament qualities, we have an estimated time of around 15.5 hours and 434 grams of filament used, or about half a roll, which is like $4 to $7. Keep in mind that some things will need to be printed multiple times, so parts like the 3 gritpin.stl requires you to print out 3 of them, so add those to the build plate as well. Now remember, your printer doesn't automatically remove stuff from the bed. Every time it finishes printing, you need to remove the parts and make sure it's clear before putting the plate back on and hitting print once more. Thankfully, with the spring steel bed plates, they are magnetic, so they're super easy to remove, and they bend, so you can just pop the parts off. And you can use a scraper to clean out the bed of the little stuff that it did during calibration, and it will be ready for the next print. Slice it, send it, repeat until you have all the parts printed for your replicant. From here, we'll remove any support material left over, which can be super easy or super taxing depending on how many little dumb factors. Now we can start putting the blaster together, which does have a full-length build guide from LeedleDynamic, so you can just follow the whole guide along. But really, it's not that hard to figure out. Just imagine your Yu-Gi-Moto sitting in your room trying to put together this ancient puzzle that houses the dark spirit of a psychotic ancient Egyptian pharaoh that is going to randomly possess you, forcing confrontation against ne'er-do-wells and games of chance or whatever the hell you want to call this until he gets into duel monsters. Really, it's not that hard to put together without a guide. Just take the pin and put it against the body and make sure you're using the right length one and put the parts in where they go. Part goes here, pin part, take bungee, cut and tie bungee snug. Maybe melt the end with a lighter or something, because fire, fire! But here's our blaster. That's right, that little magical machine made this, and man, it's freaking beautiful, but the question is, how does it perform? Loading the Replicant is super fun, because when you prime the slide back, it swings open a loading gate that reveals a chamber in the 6-round cylinder. Just push in your half-length dart so it's nice and flush and manually index the cylinder clockwise. It has a stop to prevent you from spinning it in the wrong way, and with a satisfying click, it locks into your next chamber. For firing a foam dart just with a couple of pennies worth of bungee, the Replicant does hit consistently, remarkably consistently at that, around 85 feet per second. Which is on par with NERF's latest and greatest with N-Series, but lacking under the pro-level category of foam flingers. But remember, this is just the starter pistol. It'll get a lot more interesting from here. Still, it's a beautiful and simple piece of engineering candy, visually stimulating and remarkably effective for what it is. Accuracy is a bit lackluster due to the propulsion style, but it's more than usable, and you can print up a few of them, give them to friends, and have a great time. It's also virtually silent, with the friction rubbing of the 3D printed layers being louder than the actual dart being thrown out of the muzzle. And you can quiet that down a bit with a little bit of grease if you're concerned. Most importantly, however, the Replicant is just fun. All of Bruce's blasters have some really beautiful mechanics built into them, and you can't go wrong with whatever you choose as your first project. All of them are great beginner-friendly options. This one just happened to not need a magazine or anything. So back to the printers. I mentioned how the closed source stuff of the Bambu Handy app is actually amazingly awesome, and now I get to nerd out about this. Bambu Handy app doesn't require a computer, and yet has a built-in model tab with Discovery where you can see and print thousands upon thousands of different things. There's even some NERF stuff already on there, and I can't stress this enough, this is amazing! This app, by far, is the best part about these printers. Find a random thing you want to print, right? Tap it, read about it, read comments on it, and just press prepare to print. Right there you can see what printer you have in the Bambu family and see multiple different printing profiles already set up for that exact object you want to print, with more being added to each model set all of the time. It's already rotated, sliced, supported, and all that jazz. People already did the work and uploaded it, so all you had to do was load filament and hit print. This is mind-blowingly cool. I cannot and will not overstate this enough. This is by far the most revolutionary thing about 3D printing. My biggest pet peeve was seeing a thing I wanted to print, downloading the files off Thingiverse or Printables or whatever, opening them up, and seeing 60 different files with cryptic names and geometry, and I have no idea where they go or what they do or anything. This eliminates all of that. Imagine if every single blaster was already on the Bambu Handy app, ready to go for whatever Bambu printer you have, and the community works together to build a literal 3D printing utopia. It even lists how much filament each thing is going to use in what colors. We're so close to a future where you can just find the blaster you want on the app, watch a video review on it, order a hardware kit for it through a link posted in the app, and watch a video of how to put it all together in one place. This is the future I dream of. No stress, no frustrations, just about as easy and simple as things can be. The fact that these features have been around for a while now and there isn't anybody capitalizing on this just amuses and frustrates me. Now that I've said it, I'm sure somebody will race to do it, but this is bar none the easiest way to not only advertise but grow this hobby, all from just a smartphone, by the way. 3D printing is as close as we can get to actual magic. It was never meant for end-use parts. 3D printing is itself a hobby, but it also elevates a lot of different hobbies, and nerfing is no exception. It's like chocolate and peanut butter. Not only can you print out a whole blaster, put it together, and have some absolute endgame gear, you can customize the bejesus out of it. There are so many blasters with so many alternate parts that if you buy it from a store, it can be a hassle to get exactly what you want, or even know that those alternate parts exist, or maybe they didn't exist at the time you ordered it. And then if something breaks, if you bought a whole finished blaster from a store, you need to order the replacement part and wait God knows how long, then you have to also figure out how to take the thing apart to put the part in yourself or ship the blaster back to the store. All these things are annoying. If you built the blaster yourself the first time, this would all be really simple and you could just replace the part if it broke, or if it got updated and now it's better. But hear me out. The real Trojan horse here, once you have a printer, there's tons of free to use programs out there for you to design your own everything. Obviously somebody had to sculpt all these 3D models you're printing, right? You can do the same, or even just little things, changing grips or sights or adding decoration and all this stuff to existing designs. It's nearly limitless what you can do, and I would be stupid not to admit that I hope this video encourages others to start designing their own stuff. Whether it's just a basic design off Tinkercad or full-on blaster development in SolidWorks or Fusion 360, you can learn these programs, design your own parts, modify existing parts, and maybe be the next huge name in the hobby who designed my newest favorite blaster, and that is my dream right there, and that's why I wanted to do this video. I had already filmed a bunch of stuff to do this exact video idea with the Maraca, but then Bambu reached out and it couldn't have been more perfect. The best 3D printer manufacturer helping me put out this video and telling you that, no, you don't have to be a genius or spend insane amounts of money to get easy to use, high quality and fast 3D printing. Bambu has made it so easy that a literal child could do it. So again, 3D printed blasters are expensive? Well, cut that cost down considerably. Buy a printer, buy some filament, buy a hardware kit, and build it yourself exactly how you want for far less. Bambu Bambu Labs has already made this process the easiest and most efficient it's ever been. So remember that affiliate link so I can afford all the filaments and whatever their next insane expensive model is coming out next year. All those links are in the description. And hey, one last thing. If you have any problems, just check out our Discord channel at discord.gg/nerf. We have a dedicated NERF 3D printing section and a dedicated NERF 3D designing section where hundreds of other people can help you and give you ideas of what to print next. Not to mention designers posting their latest works and even showing you works in progress. It's the best, but you're gonna make it even better.